So let I am going to start the orthographic projections. Orthographic projections. So the orthographic projections means the transformation of 3D to the 2D. So 3D means three-dimensional object. So by seeing of the 3D, we go for to draw the front view, top view, left side view, right side view, and some cases, special cases, we go for to draw the bottom view also. So that is depends upon the, so whatever the directions that he has represented in the given question. Okay, right. So here, for example, see this one. This is the object. This is the object. It is a three-dimensional object. See the dimensions for this one. So the length is 100 and the width is 50 and the height is 40. So this is the object. This one is a 3D or 2D? 3D. This is a 3D. So whenever the three dimensions are there, that is length, width and height. So the object will be considered as the three-dimensional object. The object will be considered as the three-dimensional object. Right. So for example, as given the direction to observe its front view is like this. So this is A direction and this is the B direction and this is the C direction. Right? Okay. So for example, if an observer stands at the in front of the object, the observer stands in front of the object. So which dimensions are visible? Length and height. So in the front view, we should observe the length and height. Only length and height. So here, whenever your concentration goes onto the width, so you will not get the accurate front view. Okay, so that means in the front view we should observe only the length and height of the object. And next come to the top view. So in the top view, we should observe only the length and width only. So that is the dimensions are length and width in top direction. And next here, the visible side view is only the left side view. Why? Because at the right side, the object was covered by the whole object. That the shape of the right side is covered by the whole object. So that whatever the actual shape which is visible in the direction of the side, we should select only that direction to observe the given side. So see this one. So here, actually the right side view is there. But this, when you want the actual right side view, you have to tilt the object towards to our direction. So here, the available side view is the left side. So that he has given the left side to observe in the direction of C. Okay? And see this one. So these are the actual directions that we are going to concentrate to obtain the different views. That is nothing but the front view, side view, and as well as the top view. So here coming to the whatever the side view is there, here the left side. So whenever we go for to follow the first angle projection, so first of all draw the front view above the XY line and draw the top view below the XY line. At the right side of the front view represent the left side. At the left side of the front view represent the right side. Right. So see this one. So for example, if we get any confusion to observe the front view, so simply, so what the dimensions are there? Length and height. So you please select that area. So that area means, see this one. So you please shade whatever the question diagram is there. That means in the question paper, so when the object is like this one, that is a three-dimensional object. If I get any confusion to observe or obtain the front view, so simply shade that area. What area? The front view area. The front view area means how we are going to obtain that one? Observe the dimensions are length and height itself. So that is, this is the length and this is the height. So simply shade this area. We are going to get one rectangle. The dimensions for that rectangle is 100 into 50. 100 into 40. 100 into 40. So this is the easy way to obtain the front view whenever the object is like this one, or whatever the object is appears in the question paper itself. And next coming to the top view. So in the top view, what the dimensions that we are going to observe?
Length and
width. See this one. So this is the length and this is the width. So here L equal to 100 and width equal to 50. Only we should concentrate on these two dimensions. So for example, already we covered one shade here. You go for the different shade. That is like this one. So this is the different shade. So in the top view, we should observe the length and width of the object. So the length is 100 and width is 50. Right. And next coming to the left side. So this is the observation from the left side direction. So what are the dimensions that we go for to observe? That is width and height. So in the any side view, observe the width and height of the given object. So here the height is 40 mm and width is 50 mm. So that is nothing but W is equal to 50 and H equal to 40. So these are the dimensions that we may observe from the left side direction or maybe the right side direction also. Right. So see this one. So how to get the front view? See this one. So first of all, draw the separation lines. See this one. So this placement for the front view, this placement for the top view, this placement for the left side view, and this placement for the right side. This is according to the first angle projection. First angle projection. Now simply observe this shape and represent here. See this one. This is the real shape in front direction. Yes. So here, from here to here, the dimension is 100 and height is 40. See this. So this is 100 and this dimension is 40. This is 40. Okay. Just to check now. So in the front view length and the top view length both are same. Am I right?
Yes, sir.
So simply on basis of the front view, project the length dimensions towards below the X line. That is like this. Now concentrate the width dimension. What about the width?
50.
So simply the top view shape is also the rectangle. The dimensions are 100 into 50. 100 into 50. See this one. This is 100 and the width is 50. And show the dimension. That means here already we have shown the length, the front view length and the top view length both are same. So don't go for to represent once again the remaining length in the top view. That is see this one. So simply, so whatever the leftover dimension, that leftover dimension is the width. So simply show the width. This is width. Okay, right. And next coming to the side view. So the side view dimensions are, it is just like a rectangle. It is not a square. Why? Because this is 50 and 40. If it is the case, the width is also 40, you will get the side view is the square. Okay, see this one. So this is the left side view. According to the first angle projection, we have to show at the right side of the front view. So simply project the height. So this is the height, that is about 40 mm obtaining from the front view. And what about the width dimension? 50. Simply this is 40 and 50 and 40 and this is 40 and 50. So this is 50 and this is 40. So this is 50 and this dimension is 40. Actually we have shown here, but very particular. If you want very particular, just show the dimension of the side view also. And simply write here, this is the front view. Front view, and this is about the top view, and this is about the specific, very specific, the left side. So this is nothing but the orthographic projection. There is a definition is also there. The definition is the projections made by the lines of sight on the plane of the projection is called as the orthographic projections. So once again, the projections made by the lines of sight on the plane of the projection is called as orthographic projections. These orthographic projections was found in 18th century by Gaspard Monge of Chinese scientist. He is a civil engineer, and at that particular time there is no mechanical drawing, there is no electrical drawing, there is no aeronautical drawing. Only one drawing is there, that is about the civil engineering drawing. So that he has concentrated a lot to obtain these particular views. That is about the sectional front view, sectional top view, and the sectional side views also. That means so nowadays the civil engineers are going to concentrate to obtain the sectional views is very difficult, even by using of the CAD also. So that the people are first they are going to made manually, and then which is used as the software copy in the CAD system, and they are going to develop with multi buildings are also, that is multi-storied buildings are also. Nowadays the civil engineers are very busy with multi-storied buildings, and as well as the high costly bridges, and as well as high length bridges. So nowadays the people are, that means the civil engineers are not going to concentrate on the material construction. So they are going to use fiber bridges, and as well as the plastic bridges, and as well as the rubber bridges are also. That means the technology is going to be improved like that. Okay, and today so all these orthographic projections are used in not only civil engineering, mechanical engineering, and electrical engineering, and aeronautical engineering is also, this particular topic is very, very important. Okay, and coming to the one more object. Is it clear?
Yes, sir.
Okay, so once again, so here when the object is like this one, when the object is like this one, for example, there is no indication of the letters. So for example, here the A is there, so that we are going to give the first priority. So first priority is the letter A is the first priority. So in that direction we go for to observe the front. So for example, there is no number, only directions are there. See this one. So in this case, in which direction that we should priorly select to observe the front? So simply there is no confusion. So observe all the dimensions. That means L equal to 100. Am I right?
Yes.
And width equal to 50. And h equal to
40.
So obviously nobody has selected to observe the front view from the top direction. Am I right? Okay. So that is the direction is going to give some information. That means you have to observe from the top direction. So that is the direction at the top. It is not at all to select the front view. So that you have to obviously either this direction or this direction. So here when this confusion is going to be takes place, so simply compare the dimensions. That means, so here the length is 100 and width is 50. So for example, there is no specific. There is 100 is there, and 50 is there, and 40 is there. And simply compare these two dimensions, 100 and 50. Which is the larger one? 100 is the larger one. So obviously we go for to select the different view from that direction only. And the remaining views ultimately depends upon the front direction. So for example, so here observer stands here to observe its front view. Ultimately this is the left side and this is about the right side. So that means compare these two dimensions and select of your own to observe or to obtain its front view. That's it. Okay, and see this one. So one more object is clear. So see this one. So it is a little bit easy task, so that we are going to get the views are very simple. Now see this one. If the object is just critical, that is like this one. It is like this. It is a reverse L shape. Am I right? It is a reverse L shape. And see the dimensions. So if the dimension is 100, and what about the specific here? Only this is the length. And this is 30. and this is also 30. Total height is 60. That's fine. And this dimension is around 50. Okay. So for example, there is no directions. There is no symbolic representation. So directions are there. And you see the dimension here also. So this is 50. It is like this. This like this. Is okay? Right. So in which direction that we go for to select the front view? So obviously, right. So give the priority A, B, and C. Right? See this one. So here, so priority first of all you have to write the dimensions. N equal to 100 and width equal to 50 and height equal to 60. These are the dimensions. Right? So here in this direction you go for to observe the different view. That means totally our concentration is going to be takes place on corners first of all. See here. Corner 1, corner 2, corner 3, corner 4, corner 5 and corner 6. Shade this area. If any student is going to concentrate on this place, you won't get the actual front. Why? Because this dimension is related to the width. Our concentration is totally takes place on the length and height of it. So if the length is 100 and height is 60. In that 60 there is a split is there. So this is 30 and this is 30. So you will get the reverse L shape. Next coming to the top. So in the top view, what are the dimensions that we are going to concentrate? Length and width. Right. So here the length is 100 and width is 50 and 50 and 50 and 50. The total width is 50. But there is a splits are there. So there is 1, 2, 3, 4, 5 and here is also there. There is a 6. 6 widths are there. So from this, so when we are going to concentrate from the top direction, only you will get the 3 widths only. How it is. See this one. When you are going to observe from the top direction, this line is going to concentrate inside this one. And this is coincide to this one. And this is coincide to, there is a bottom width is there at the back side. So that we will get only 3 widths. That is 1, 2 and 3. So that is, it is coincide to this one, it is coincide to this one and this is coincide to the bottom one. That means if you want, I am going to represent in the dotted manner also. See this one. So this width is going to concentrate at the bottom which is parallel to the front width. That is, this is 50 and this is also 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 50 and finally this width is also the 50. Okay. So when you are going to observe from the top direction, 1, 2, 3 lines are only visible. So when you will get the perfect front view, the obtaining of the top is very, very easy. See this one. Is it right? The front view?
Yes, sir.
So this is 100, this is 30 and this is 30. Total height is 60 and this is 50 and this is 50. See here, there is no split here. Ourselves we go for to divide into equal lengths. So this is 50 and as well as that is the remaining is also the 50. See this one. So this is 100. Here there is a split is there. So project a line with a light line. Use the H pencil, lighter pencil, and this is 30, and this is also 30. And simply show one half of the length. This is 50. So remaining is 40. That is the remaining is the 50. Why? Because we have shown the total length of it. And next to concentrate the top view. So in the top view, we go for to observe. See this one. These surfaces. So when we go for to observe from the top direction, this space and this space are going to come to onto the same balance line. See this one. Just project edge number 1 and edge number 2 and edge number 3. Right? And this hatching lines. So hatching surface at the bottom and a hatching surface at the top. So these are comes to the top. See here. So this is 50 and this is 50 and the width is 60. 50. This. So that is about the top. And next come to the side. So when you are going to observe from this direction, this rectangle and this rectangle are only visible from the left side direction. Why? Because in the left side view, we are going to observe the dimensions are width and height. So the width is 50 and height is 30 and see this one. So simply project. This is 30 and this is also 30. Total height is 60. See this dimension. This is 50 and these dimensions are 30 and 30. Individually, this 30 and this is also 30. So this is the front view, top view, and this is the side. So that is about the second object. Okay? Right. We go for one more. See this one. Is it clear? Yes. Right. And see this one. Identify the object. It is a step. See the dimensions for this one. So this dimension is length is 90 and this is 45. This is 45 and this dimension is 50. This is 50. Right? So here individually this is 15, 15, 15. So this is 15 and this dimension is 30. It's enough. It is not required to give all the steps dimensions. So if one is there, we go for imagine the same and same. So this is 50 and 15 and 15. Total it is 45. So 3 15s are 45. And next coming to the length. So this is 30 and 30 and 30. So in the final examination also, there are breakup dimensions that is going to concentrate on the object. So that means ourselves we go for to imagine. So which is exactly split dimension is suitable for the total dimension. So there is a 90 is there. There are 3 splits are there. So we go for to divide into 30, 30, 30 like that one. So similarly there is a 45 dimension is there. So 15, 15, 15 like that one. So there are only 2 steps are there. There is a 60 dimension is there. We go for to divide into 30 and 30. If individually dimension is there, you have to select the individual dimension. If it is not like that one, ourselves we go for to divide into the equal spaces. Right. So see this one. Observe from this direction. This is x and this is y and this one is y. So simply, first of all, consider all the dimensions, that is l equal to 90 and width equal to 50 and height equal to 45. So these are the basic steps to identify each dimensions first of all. Later you have to concentrate. So in front direction, whatever the shape that we will get. Similarly, in the top direction, whatever the shape that we will get. In the left side view or the right side, whatever the shape that we will get. See this one. See one more information for you. When we are going to draw this plane spaces, so these are the plane spaces. So these plane spaces are just more than the dimension of the object. So for example, see here, it is 90. The space between from this line to this line is more than 120. So because there is a dimension space is required after representation of the view. So see this one. This is the front view. Is it right?
Yes.
If you have any doubt, please check here. Shade this area. Shade this area. So the shaded area is as per the shape or not?
Yes.
Okay, and then concentrate the dimensions. That is series one. This is 90. And show these dimensions individually. 50. This is 30. This is also 30. And finally, it is also 30. Okay, and coming to the height. So in the height, the total height is 45 and the splits are 15, 15, 15. See here. See how I am going to maintain the chalk piece. That means these are the actual lines. That is nothing but the object lines. For representation of the object lines, you please use the HP pencil. And for the projection lines, you please use 2H pencil. For the dimension lines, you please use the H pencil. See this one. So these are the object lines, use the HP pencil. These are the dimension lines, use the H pencil. And these are the projection lines, use the 2H pencil. So this is 50, 50, and this is 50. And next to concentrate the top view. So in the top view, we will get 3 rectangles. See here, I am going to tick this one. 1, 2, 1, 2, and 3. This is not visible, and this is also not visible. Why? Why? Because when we are going to observe from the top direction, this line is coincide to this one. So this total area is going to coincide with the observer. Similarly, this is coincide to this line. So this space is parallel to the observer. And similarly, it is coincide to this one. So this space is parallel to the observer. So that this one and this one and this one is not visible from the top direction. So simply concentrate the front view and project the corner lines. You will get automatically the top view. See this one. 1, 2, 3, and this is. See 3 spaces. So that is this area is nothing but this one, and this space is meant for this one, and this space is meant for this one. So simply maintain the width. Whatever the width here, this is 50. 50. See here. This is the top. That is rectangle 1, rectangle 2, and rectangle 3. This is 30, and this one is also 30. Total length is 90. And coming to the width. So here I am going to tell one more method. So how to transfer the width onto the side view. Okay, so see here, this dimension is 50. The width is 50. So here, the getting of the side view is very, very simple. Okay, so already the height is projecting from the front view, and the width that we are going to transfer by means of radius method or by means of the angle method. See this one. So simply draw the 45 degrees inclination from this intersecting point. This is 45 degrees inclination. Just to project this width. See here, projection line, and this is also the projection line. And next, turn up these projections to the above xy. That is like this. So whatever the dimension is there in the top view, that the dimension has a transfer onto the right side of the front. Right side of the front view. Now project these lines. See this one. 1, 2, 3, and 4. So in the side view, how many rectangles are visible? Whatever the cross lines, cross spaces are there in the top view. So all these cross spaces are visible from the left side. See this one. This is visible, and this is visible, and this is visible. So whatever the total height is 45, 15, 15, 15. Total height is 45, and width is 50. See this one? A rectangle 1, rectangle 2, and rectangle 3. This is the bottom one, middle one, and the top one. So simply take the HB pencil and pick these lines. See this one. How simple to obtain the left side. The similar method which is used in the left side is also. Whenever you may ask. So this is 50, 50, and 50, and the width is 50. This is, and this one is the front view, and top view, and this is the left side. These are the views. This is a very simple method to obtain the side, any side view, either the left side view or the right side view. If you want the left side view, project these lines towards the right side of the front. If you want the right side view, project these lines towards the left side. See one more object. See this is a different item. See this. So there is a flat is there. In that flat there is a groove is there. Behind of the flat, that means at the back side of the flat there is a inclined wall is there. So this is the inclined wall, and this is the base. In that base there is a rectangular groove is there. This is usually available in the previous question papers. See this one. These are the dimensions. So this dimension is 25. This is also 25, and this is also 25. Total length is 75. And see the width. So here this width is 45, and the base height is 15, and the wall height is 30, and this land width is around 20. So this is 20, and this is 45, and the remaining one is 25. So these are the calculations are required. And this space is 50, and this space is 50. Okay, and select this way, and the depth of this groove is around 10. So this is that. Okay, now see in this direction. So this is A and B, and this is this. For example, I think so it is a little bit difficult component, very difficult component is, so that it will take a different color. So usually a student is going to use the black color. So usually it's going to take the blue color, and with the blue pen. So in this direction, what the area which is visible? That means already we had some calculation. So that calculation is length and height. So see this one. So this is the length and height, and this is groove is also visible from the front direction, and this area is also visible from the front direction, and this area is also visible from the front direction. See this one. If any student is going to feel any difficult, so you please use this method, so that you will get the front view and as well as the top view and as well as the side view. Is very simple. See this one. In the front direction, the total length is 75 and height is 15, which is related to the base. So in the base, there are 3 lines are there. That is 1, 2, 3, and the last one is 4. So there is 1, 2, 3 lines are getting in the base. And next, this area is projected towards the front direction. See the front. See here, these are the spaces. Okay. So the total length is 75 and base height is 50. First of all, finish this one. See. So this height is 50, 25, 25, 25. This is 25. And next, concentrate on this one. When you are going to observe from this direction, this wall is coincide to here, and this slope is coincide to here. See this one. So the height of the wall is 30, and this is 15, and this is joint 15 from the front direction. That means, you please make a dimension here 15, and this is 15, and join this slope. So you will get the front. Now observe the shaded area which is equal to that one or not? Yes. Same space. Right. And next to concentrate the top direction. So forget about this shaded area. That is only related to the front area. And next, in the top direction, this is visible, and whole this space is visible from the top direction. So simply project from the front. See. So this is 15, and this is 30, and this is 15, and this space is 15. That is simply project all the corner points towards to the below X. You will get the top. Very easy. See this one. See. Okay. First of all, concentrate this rectangle and this space here. See here. That is the top. Is clear? See once again. This space is this one. Am I right?
Yes, sir.
And this space is this one. And this area is, see here, this is the area. So from the top direction, the groove is directly visible from through. That is from top to bottom. So see here, when we are going to throw a stone which is falls like this one. So why? Because there is a groove is there. So through that groove, the stone is freely passed onto the ground. So that the groove is visible from the top direction. So that is the way we are going to obtain the top. See the dimensions. So this is 25. Am I right? Yes. And this is 20. Total? 45. See here?
Yes.
That's why.
75.
This is 25. This is 25. and this is 20. Total is 75. It is coincide to the dimensions or not. Actual projected dimensions are must and should equal to the actual dimensions. So these are the actual dimensions and these are the projected dimensions. So these two must are equal. And see this one. So this gap is 50, already is there. It is not required here. And this dimension is already there. It is 20. Next to concentrate what? 10 mm. So see this one. So this is the 10 mm. That is the groove depth. The groove depth is or groove width is 10 mm. Now concentrate the side. So you please observe from this direction. So in this direction, this rectangle is visible, and this slope rectangle is also visible, and this groove is not visible from the left side. Why? Because so this area is covered to this groove, so that this groove is not visible. So that here we will go for to indicate the dotted line in the side. See here. Simply project these lines. Project these lines and draw the intersecting point to the 45 degrees inclination. Now project these dimensions to this 45 degrees inclination line, including the width also. So that is the groove also. See, it is from here to here it is 45. From here to here it is 20. Here to it is 25. From here to it is 10. See how simple that you are going to get the left side. Okay, if you feel any difficult, simply mark the corner points. See here. This is visible. This is visible. This is visible. And this is visible. This is not visible. See here. That is the left side. Simply it is the L shape and this groove is not visible. So this is the dotted line. And remove these lines. We will get the accurate. See there. So this is the L shape and this is the thicker line also. Why? Because there is a split is there from the base to the wall. So this is the base and this is the wall. So this line is coincide to here and there is a joint is clearly visible from wall to the base. So this is the wall and this is the base. And this dotted line meant for so the groove is not visible from the left side direction. And see the dimensions. So this is 20 and this dimension is 25 and specially it is 10. And this dimension is 50. That's it. So that is about the front view, top view and the left side. Front view. And this is the left side. Left side view. And this is about the okay. And one more object which is only specially related to the right side. See this one. See this object. But it's the same, just a different from the previous. Now it is the 8. That is front view, and now this is the right side. What is the? See the dimensions. This is 108. This is 90. And this dimension is 45. And here this gap is 28. So 28 means 108 out of 28 means
90.
80. This is 80. So 80 plus 28, 100. And this is also 28. Okay. So this one is 30, 30 and 30. So this is 30. So 30, 30, 30. So that is total it is 90 and 50, 50, 50. So specifically I am to show here. So this is, so it is object, no problem to show that inside dimensions. So this is 50. So 50, 50 and 50. So in this direction you go for observe the front. Okay. So when the observer is at this position, he will get the views, this L shape and this rectangle and this rectangle. Okay. So especially you go for the shape. If you feel any difficult, use this method only. See, it is clearly visible which area that we are going to concentrate to obtain the functional view. So this is the L shape and rectangle one and rectangle. So in the top direction there is a L shape, rectangle, rectangle. In the right side view, these are the reverse steps and this area is also visible. See, this one is a right side view. So these hatching lines are only what the hatching area is there. So this hatching area is only visible from the right side. Okay, see the points. See the space first of all. See, here I have allotted very smaller area. Why? Because there is no left side. So here I have allotted the bigger area to represent the right side. That's fine. See this one. Is it right?
Yes, sir.
The front view, L shape, rectangle, and the dimensions are. This is 108 and this is 45. Height is 45 and this dimension is 20. That's all. That is the front. Next to concentrate the top. Reverse L, rectangle 1, rectangle 2. Is it right?
Sir.
That is the top. And the dimensions are, this is 80, 25 and this is 48 and these dimensions are 30, 30, 30.
90.
So this is 30 and this is 30 and this is. Now turn up the top view width onto the left side. And then project the front view dimensions. See this. This is the right side. So observe the hatching lines here. So these are the hatched area and this is also the hatched area. So that is this steps area and back side area. So this is about the right side. Observe the dimensions. So this is 30, 30 and 30, and these dimensions are 15, 15 and 20. Okay, so total height is 45, total width is 90, and total length is 108. And see the specific, that is the front view. And top view. And this is about the right side.
Right side. Lines.
Right side.
20.
Okay. So this is about the just the concept of the orthographic.